Have you ever wondered why loading a website across the globe feels slower than one hosted nearby? Is it just perception, or is there a fundamental reason that distance seems to slow everything down? The answer is a resounding yes. Distance absolutely influences round-trip time, or RTT. It is a fundamental physical limitation, as data cannot travel faster than the speed of light. The primary reason behind this is propagation delay. Data, whether it is light signals in fiber optic cables or electrical signals in copper wires, travels at a finite, albeit very high, speed. Every mile or kilometer a signal traverses adds a tiny fraction of a second to its journey. While seemingly minuscule at short distances, these delays accumulate significantly over long distances, such as across continents or oceans. This constant speed limit, often referred to as the speed of light barrier, means that the further the 2 points are from each other, the longer it will inherently take for a signal to make the round trip. Additionally, network devices like routers and switches introduce small processing delays, but these are generally dwarfed by the propagation delay on wide area networks. Understanding this principle helps us optimize network performance. For example, if you are designing a system that requires very low latency, you would logically place your servers physically closer to your target users. This often involves utilizing content delivery networks, or CDNs, which cache content at various geographical locations. By minimizing the physical distance data needs to travel, you directly reduce the propagation delay component of the round-trip time, thereby improving user experience. It also informs decisions about routing paths. A path with fewer intermediate hops and a more direct physical route will generally result in lower RTT. Beyond simple propagation delay, there is also the concept of serialization delay, which is the time it takes to place bits onto the transmission medium, and processing delay, the time taken by network devices to handle packets. However, for long distances, propagation delay is overwhelmingly the dominant factor. Interestingly, the type of medium also plays a role. Light travels faster in a vacuum than in glass fiber, meaning even with fiber optics, the speed is slightly less than the absolute speed of light. Every architectural choice in networking is a delicate balance of these physical realities. Ultimately, the direct relationship between distance and round-trip time underscores a core principle of networking. The physical world dictates fundamental limits. By recognizing that every mile adds to the delay, engineers and designers can strategically position resources and optimize routing paths to minimize these unavoidable physical constraints, ensuring a more responsive and efficient digital experience for everyone.
If you love understanding how the web works, like, subscribe, and stay connected with us.